Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called What Number Am I Thinking of? S by Brigitte. And here are the rules. We need to pick 6 digits from 1 through 9. And we need to place those 6 digits in each row, column, and box. Now you say there's 5 cells, so how do we get 6 digits in each cell? Well, I'm glad you asked. We have also Schrödinger cells, where some cells contain 2 digits. And it is up to the solver. Actually, it said box. This should be region, right? Yeah, these aren't. Oh, interesting. There are some 4-cell regions here too. Some cells contain 2 digits. It is up to the solver to find these S cells. So, in each row, column, and region, you have to have 6 digits in them. And some of the digits can contain 2 digits. And those are called Schrödinger cells. Note, S cells are not taken into account whilst checking for the solution. Only pencil mark them. Okay. So for the puzzle to actually figure out if you solved it, it only takes into account the larger numbers. We have parity, where digits placed in a gray circle are odd, and digits placed in a gray square are even. That speaks for itself. We have crop key dots, where digits connected by a white dot are consecutive, and digits connected by a black dot are in a 1:2 ratio. So, for example, if this were, say, a 6, this would have to be 5 or 7. Or it could be 5 and 7, too, here, right? So if this is 6, and these digits have to be consecutive with the digits in that cell. But since we can have Schrödinger cells, it would have to be consecutive with both of them if it was a Schrödinger cell. That's interesting. And if we had a 2 here, this would have to be 1 or 4 or both, right? So that could also be the case. Anyways, those are all the rules. And love Brigitte. Those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we're going to mark non-Schrödinger cells as blue. And any 6-cell region cannot have a Schrödinger cell. Well, where's the Schrödinger cell then? There's going to be one Schrödinger cell per row and per column. So, where's the Schrödinger cell in column 1? It must be there. Where's the Schrödinger cell in column 5? It has to be there. That means in row 1, we do not have a Schrödinger cell. Sorry, yes, row 1, and then the rest of row 5 does not either. So we have one more Schrödinger cell in one of these 2 cells. We have one more Schrödinger cell here. So this is consecutive with this digit here. It cannot be a Schrödinger cell. So one of these 2 is Schrödinger because we have only 4 cells in this region. Therefore, this cannot be Schrödinger there. One of these cells is Schrödinger, so this can't be Schrödinger there. Okay. We have overall we have definitely 2 odds and 2 even digits for all the digits in each row and column. This then is consecutive with both of these digits here are consecutive with this one. Okay. There are digits here can be 1, 2, 3, 4, 6, and 8. Obviously, if one of them has to be Schrodinger. Because we don't have Schrodinger's in the rest of column 4. So, then it's going to be 2. So 2 and 4 are guaranteed to be here. So we have a guaranteed 2 and 4 in this puzzle. Because for the Schrodinger to be in a 1 to 2 ratio, with both of the digits, both of the Schrodinger digits must be 1 and 1 to 2 ratio with another digit. So it's either 2 with 1 or 4 with 2 or 8. But we don't know which one. Okay. These two digits are consecutive with that. So we have a guaranteed 2 and 4, and then 1 out of 1 or 8 here. We don't necessarily have 2 odds. Well, we do have to have 2 odds because you have to choose 2. You can only have 4 evens at most in this puzzle because, again, it's digits 1 through 9, right? So, So you guaranteed have 2 odds. We also guaranteed have 2 evens. Can this be the Schrodinger? I guess? Then that would be 2 evens here. This would be not Schrodinger, so this would be Schrodinger. You would have a guaranteed 3 evens then, at least in this puzzle. Because you'd have 2 evens here, and one of these would be 2 or 4. To be in a 1 to 2 ratio with 2 other unique digits. Interesting. Okay, what happens... This digit is consecutive with this one. So therefore, you could have 2 odds there. So one of these is going to be Schrodinger, right? We know one of these is Schrodinger, one of those is Schrodinger. You could have Schrodinger, Schrodinger, Schrodinger. Schrodinger, Schrodinger, Schrodinger. Schrodinger, 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 Schrodinger. Oh. Interesting. Where is this digit? Say this was non-Schrodinger. Well, if this was Schrodinger, this can't be Schrodinger. If this were Schrodinger, where would it be? Where would these digits be in row 1? They could not be here because they're in the same region. They cannot be here because they would be in the same column. They would both have to be these two digits. But this digit is specifically odd. So this cannot be Schrodinger, which means this is not Schrodinger. This then has to be Schrodinger, which means this can't be Schrodinger. So this is guaranteed to be 2 or 4. And this is either 1, 4 or this is 2, 8 as a pair. But these three digits cannot appear in row 1 in this region, so they have to appear in these three cells. And one of them is an odd digit, which means this has to be 1 and 4 here, which is in a 1 to 2 ratio, and this must be a 1 here. So we have 1 and 4 here. That's in a 1 to 2 ratio with 2. So this is 2. Same with this. This can't be Schrodinger because if this is Schrodinger, they're both even. And where would they be in row 5? They cannot be in this region because they're already in that region. They can't be here because they're in the same column. So they would both have to be this digit, which means this is non-Schrodinger. So this is Schrodinger here. And whatever digit is here have to be 2 of the digits here. Have to specifically be these two. This one must be the same as this. So this is Schrodinger here. So all the Schrodinger cells are there. Okay, let's mark certain digits. This digit, where are these two digits? We're going to make this one yellow and this one pink. Pink cannot be here or here. It can't be the odd digit. It has to be here. Yellow cannot be here or here, and it can't be the odd digit. It's there, that digit there. So pink cannot be in this region here. Can't be here, can't be in Schrodinger. So pink is one of those two in row 5. Yellow cannot be here, cannot be this one. So yellow has to be one of those two here. Yellow's here and yellow's here. So yellow has to be in the Schrodinger there. So yellow has to be one of these two. Pink is here, here, and one of those two. Pink cannot be here, so pink is in the Schrodinger. And then pink can be one of those two. So pink is even. And it's in the Schrodinger. So this must be an odd digit. So this is 1, 3, 5, 7, 9. And this has to be 2, 4, 6, 8. Yellow cannot be 4 or 2 because we have a 1, 2, 4 pair here, or triplet here. 1 cannot be here in this region. 1 has to be one of these two. That means this can't be 1. 1 can't be here because of 1 in the column. So 1 has to be one of the digits here in this Schrodinger. Okay. Because there's no other place for 1 in the central region. We already have a 1 in this region. So this is an even digit. We have a guaranteed 1 here, which means this can't be 1 here. This can't be 1. So 1 has to be one of these two digits here in the bottom right region. Okay. This digit is consecutive with both of these digits, so it can't be 1 or 9, which means whereas 1 in this lower left-hand region, it has to be here in the Schrodinger. So this is 1 which eliminates 1 there, so therefore this is 1 there. This is an even digit which cannot be 2 or 4. So this is guaranteed to be 6 or 8. Um, hmm. 4 cannot be here. Cannot be here. So 4 is definitely one of these two digits. Ah. Where is 4 then in column 1? Can't be here because we're guaranteed 4 here. Because 4 cannot be here in row 1. It has to be one of these two. That means 4 can't be here, so we're guaranteed a 4 here. And it has to be 2 or 8 along with it to be consecutive with 3 or 5. Okay. Where is 4 definitely has to be here in row 5. Where is 4 in column 3? It could be there. Hmm. So 2 has to be one of these two digits here. Where is this digit in this region here? This is an even digit, so it can't be there. It's not 1 or 4. So this digit is guaranteed to be one of these two digits here. And the thing is, so okay, where is this digit then at all? Let's make it orange. In this bottom right region, it must be one of these three, so it cannot be here. So in this upper right-hand region, it can't be even, it can't be 1 or 4, it can't be here because one of these is, so this is guaranteed to be the orange here. So where is the orange in column 3? It has to be in the Schrodinger cell. So this is 1 with 3, or this is with 1 with the orange here. We have 1 here, we have 1 here. So the orange is here, which means this can't be orange. So one of these two is orange, which means one of these two is orange. 4 cannot be here anymore. Where's 4 in the central region? It has to be one of these two, which eliminates 4 in the rest of the column, so this can't be 4, which means this... Oh, it couldn't be 4 anyways because it's pink, right? So this is whatever digit is pink. So this must be either 2 or 6 here. This is guaranteed to be 4. 4 cannot be here because we have a Schrodinger cell there, so 4 has to be here. It's not the same as orange or yellow, so therefore, which one's yellow? It has to be this one, which means this can't be yellow, so yellow is there. This is 2 or 6. We don't know which one of the oranges here. Four is here. This digit cannot be here, is not 3 or 5, and is not that digit here. So what is the other digit in the Schrodinger? It has to be the same as that, which is a 2. So 2 cannot be pink. And therefore, this is pink, which means this can't be pink here. That's pink there. So the pink has to be 6. So these are, we'll exclude that one. Those are 6. This then must be 4 and 6 here, which is only consecutive with 5. So we have 5 here. This is not 3. That means the yellow is 8. So we have the digits in this puzzle are 1, 2, 4, 5, 6, and 8. So all the yellows are... all the yellows are 8. This has to be 8, and it has to have 2 with it, because there's no other place for that. That means this is a 5. And then, what do we have left? This can't be 4 because of 4 in the row. So where is 4? It has to be here, which means this isn't orange, which means that's orange, so this can't be orange there. So this has to be 5 here. This is, 4 here. All the oranges are 5. And this must be a 2. And this is a 2 there. All cats are beautiful. Don't kill them. Okay. I mean, I would say, yeah, don't kill things which you don't need to, but... yeah. Oh, because it's Schrodinger. Ah, I see. It's a Schrodinger cat, right? So don't kill the Schrodinger cat. But the thing is, the point is that, well, I don't know. The cat is in a state of not being killed and being killed at the same time. So that's hard to say. Very cool. I really enjoyed these uses of these Schrodinger cells with the Kropke dots. That was very interesting. And then also, this was very cool logic with the squares and then the circles. So well done overall. Yeah, this was actually a really cool puzzle. A lot more people should have tried this. This is a very interesting puzzle, and then the logic and the limitations between Schrodinger cells and what can and can't be as possibilities. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.